In this lesson, we're going to talk about bisectors. And with bisectors, we're going to talk about two of them, an angle bisector and a perpendicular bisector. So first we're going to look at is an angle bisector. So in this particular diagram, we have an angle listed here. The line going through the middle is what we're going to call the angle bisector. And that angle bisector does some things to the angle where we get some properties. So in this particular case, the distance from the point to a line is the length of the perpendicular segment to the point on the line. Essentially what this is saying, if you have a point on the perpendicular bisector line, so in this case point D, if you were to draw a perpendicular line to the angle, to the side of the angle, this distance and this distance, again perpendicular to the angle from the point, is the same. So this line length and this line length are going to be congruent. So all that's really saying is that. So in this theorem, that's essentially what we're talking about, is this distance and this distance is the same when you have a perpendicular angle bisector. Now the angle itself, by definition, means it gets bisected, which means it gets split in half. So if this whole angle was 30, this part would be 15, and this part would be 15. If we had an algebra expression, which we'll see in a few minutes, this part would equal to this part, and then we would use our congruent equation to solve those types of problems. All right, so here's an example here. It says find the value of x, then find FD and FB. So if we look at the picture, the work is already done for you on your notes. So here, these two congruent marks tell you that this is an angle bisector. These two perpendicular lines tell you that we need to use the theorem from the prior slide. So that means that this length, BF, is the same length as FD. So if we look here, 5x, this length, is going to be equal to 2x plus 24. So we subtract 2x, which is our smallest variable, and then divide by 3, we get x equals to 8, which is good. And now we have to plug in for FD. So FD and FB are the same. So in this case, they used FB, which is easier to do. So you take x and plug it in, so 5 times 8, which is 40, and because they're the same length, we only have to do it once. So this is an example of a problem where we take the property of an angle bisector and the distance from that bisector to the angles to solve for side length problems. All right, so again, think about what property occurs with angle bisectors. We get two congruent angles, and the distances from the angle bisector line perpendicular to the angle are going to be congruent. So because these distances are congruent, based on the previous slide that we talked about, we're going to set up a congruent equation. Okay? Again, also pay attention to the directions. In this problem, it asks to solve for x and then substitute it back in. So definitely pay attention to that as we do problems in class. All right, here's another one. So in this diagram, they don't tell you this is an angle bisector yet. What you have to know is that this distance perpendicularly to this line and that line is the same. And because these are the same distances, these angles are bisected. So knowing that then, how far is K, which is here, from EH? So EH is here, so K is 10, and it's also going to be 10 from DE. So based on the diagram, that's what you end up getting. All right, to find the value of x, we're going to set this equation equal to this one. So 2x is equal to x plus 20. We subtract our smallest variable, and in this case, we get an answer of 20. Now, to find angle DEH, in this case, DEH is the entire thing. We're going to find out how much each part is. So what we're going to do first is do x plus 20. So if we take the x and substitute it in, we get 40 degrees for the angle on the bottom. If we substitute x up here, 2 times 20, we get 40 for the angle on top. So the entire angle then is going to be 80 degrees. All right, the next bisector is called a perpendicular bisector, and a perpendicular bisector is going to be a line that splits another line in half at a right angle. In other words, it's going to split it in half perpendicularly. Similar to the angle bisector, we have theorems which are going to talk about what happens. So in this particular problem, BD is a line that is bisected perpendicularly by AC. And what happens then is BE is going to be congruent to ED or DE. So these two segments are congruent. Now, the actual perpendicular bisector, based on that, is not always congruent. It does happen occasionally, but the line that is bisected is the one that is cut in half into two equal portions. So all this is saying is that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoint of the segment. Okay, so that's just a quick summary of what that's saying. So in this particular problem, we want to find AB. So in this case, AB is here, and AB is going to be congruent to AD. Again, going back to here, here's your perpendicular bisector, and if you connect this endpoint and this endpoint, these two endpoints are going to be the same. So what actually is created is what we call an isosceles triangle. At this point of the course, we haven't talked about it in much detail, but we'll get into it. Now, BC is going to be the same as CD. So if this is 18, this will also be 18. And then ED is going to be the same as BE. So if this is 8, this has to be 8 as well. All right, here's some more examples just to kind of reinforce this concept. The problems aren't really hard, so I'm hoping that you see the pattern of these types of examples. All right, so how is WY and XZ related? Well, WY is the perpendicular bisector of line XZ. And we notice that because it splits it into two equal parts. Okay, so find XV then. Well, XV is going to be the same as VZ, which is 4. All right, to find WZ, that's this section, it's going to be the same as WX, which is 7.5. XY is this particular line, and that's going to be the same as ZY, which is going to be 9. And then they just ask, what kind of triangle is WXV? So WXV is going to be a right triangle. Okay, let's look at another example now. All right, find the value of x. So because this is a perpendicular bisector, because these two are the same distance, this is a perpendicular bisector, and that means that this is going to be equal to that. So we set up our congruent equation. We move our smallest variable first, and then we move numbers to the other side, and we get x. Now, to find HI is this. We're going to plug in x. So we do 3 times 5 plus 2, which is 17. Over here is JI. So we do 4 times 5 minus 3, which is also going to be 17. All right, now here it says if L lies on KI, so KI is here, and if we had a point L here, then L is blank from H and J. So any point on this perpendicular bisector is going to be equidistant from the segment endpoints, and that's what the previous slide talked about. All right, what kind of triangle is HIJ? HIJ is going to be what we call an isosceles triangle because this side and this side are congruent. All right, next example, what is the value of y? So if we look here, we have the two angle symbols, which tells us this is bisected by this line. We also have two right angles here. Now, because this is a bisector, these two are going to be congruent to each other. So 6y would equal to 8y minus 7. Now, this is going to be a little bit tricky equation, although the steps we do are the same, just the way it's presented is a little bit different. So we're going to subtract 6y from both sides, and so we get 0 on the left and then 2y minus 7, and this is where everyone gets confused. Because the variables are on one side, we want the numbers to the other side, so we're going to add 7 to both sides, and we'll end up with 3.5 as our value. So now here, if we want to find PS is 6y, so 6 times 3.5 is going to be 21. Then we want to find RS, so you plug that in, and we would get a value of 21 as well. And in this case, what kind of triangle is PQS? PQS is going to be a right triangle.